Reaction takes place at room temperature. Then there is formation of 2-chloropropane, no doubt. But here turbidity form after 5 minutes because secondary alcohols are less reactive. म्हणजे आपण जर अल्कोहोल मध्ये लुकास रिएजंट ऍड केला, इमिजिएट टर्बिडिटी फॉर्म झाली टर्शियरी अल्कोहोल्स, आणि लुकास रिएजंट अल्कोहोल मध्ये ऍड केल्यानंतर टर्बिडिटी 5 मिनिटांनंतर फॉर्म झाली, थोड्या वेळानंतर फॉर्म झाली, तर दॅट अल्कोहोल्स आर सेकंडरी अल्कोहोल्स. And one more point here you have to remember. Now we have to take example of primary alcohol. Here I have taken primary alcohol, that is ethanol. Now see, when Lucas reagent is added in primary alcohol like ethanol, then there is no turbidity form. Why no turbidity form? Because primary alcohols are less reactive. Primary alcohols are less reactive. Therefore, here reaction does not take place. But if we heat this mixture strongly, जर आपण हे mixture strongly heat केलं, त्याला जर जोरात heat दिली, जास्त heat दिली, तर मात्र त्या ठिकाणी turbidity is obtained. म्हणजे if the turbidity is formed on strong heating, then that alcohols are primary alcohol, and in this way tertiary alcohol, secondary alcohols and primary alcohol can be distinguished from one another. That is, tertiary alcohol with Lucas reagent form immediate turbidity, cloudiness from tertiary chloride. Secondary alcohol with Lucas reagent form turbidity but after 5 minutes, and primary alcohol does not form turbidity, or they cannot form turbidity, but they form turbidity on strong heating, and this is due to their order of reactivity. So this is the action of HCl, or this test is called as the Lucas test. Now see the next one, that is action of HBr on the alcohols. Action of hydrogen bromide. Similarly, instead of HCl only we have taken here HBr. Now this reaction HBr takes place in the presence of sodium bromide and what, that is the H2SO4. So here see alcohol when treated with HBr, म्हणजे actually NaBr with H2SO4 form this HBr and they form bromoalkane or alkyl bromide. Only here you have to remember general reaction, general equation, that is OH replaced by bromine to produce alkyl bromide. Ethyl alcohol gives ethyl bromide, isopropyl alcohol gives isopropyl bromide, and tertiary butyl alcohol gives tertiary butyl bromide. You can practice it. You can practice 5-6 example taking methanol, ethanol, propanol, propane-2-ol, tertiary butyl alcohol, butane-2-ol, and if you practice it, you can write any reaction or example which is asked. Now, next one, that is the action of hydriodic acid, HI, hydriodic acid. As we have studied in the beginning, in this reaction, the reactivity of hydriodic acid is most. Hydriodic acid is the most reactive. Therefore, it does not require any reagent or does not require any catalyst. So alcohols when treated with hydroiodic acid, that is HI, they need form iodoalkanes. Here OH group of alcohol is replaced by iodine and that form iodoalkane. Specific examples similarly you have to practice by taking methanol, ethanol, propanol, propane-2-ol, butane-2-ol, tertiary butyl alcohol. एवढे equations लिहिल्यानंतर we can write the any equation if asked from this. So this is the first one, reaction, that is reaction of alcohol with the hydrogen halides. Now we have to study the next one, reaction. So here you remember all these reactions are nucleophilic substitution reaction, is earlier. Now see the next one, reaction, that is reaction with phosphorus halides and SOCl2, that is thionyl chloride. Okay, this reaction also we have studied in haloalkanes to prepare the alkyl chloride, and the same reaction here we have to revise. These are nothing but alcohol when treated with phosphorus halide म्हणजे phosphorus trichloride, phosphorus pentachloride, thionyl chloride. You can also take the phosphorus triiodide, phosphorus tribromide, and they can form or it can form the chloride, bromides and iodide. So alcohols when treated with phosphorus trichloride, then it gives the alkyl chloride. In this reaction, if alcohol treated with PCl3 or PCl5, here we will observe product is same, alkyl chloride. So these reactions are characterized by the byproduct. म्हणजे या रिएक्शन बायप्रोडक्ट ने कॅरेक्टराइज केल्या जातात की त्याच्यामध्ये बायप्रोडक्ट काय आहे. When alcohols treated with phosphorus trichloride, then the byproduct obtained is phosphorus acid. It is phosphorus acid. Main product is alkyl chloride. Here OH replaced by chlorine. Then second here PCl5, phosphorus pentachloride, and alcohol gives the same product, alkyl chloride, but byproduct are different, phosphoryl chloride and HCl. If alcohols treated with thionyl chloride, SOCl2, this reaction is take place in the presence of basic medium, that is pyridine. Why? Because the yield of product is good in basic medium, and here there is formation of what, that is the alkyl chloride, and in this reaction sulfur dioxide gas is liberated as well as HCl is removed, HCl is evolved. म्हणून तुम्हाला क्वेश्चन असा असेल की हे 3-4 इक्वेशन्स देतील 4 ऑप्शन मध्ये आणि विचारतील which of the following reaction is most suitable or perfect to prepare the alkyl chlorides from alcohol. Answer हे सांगायचं आहे का तर in this reaction byproduct from both are gases, they are escaped out from the reaction, and main product does not require separation from the byproduct. Main product byproduct पासून separation करण्याची गरज नाही. So that is nothing but the formation of alkyl chloride, that is SO2 and HCl is byproduct. So this is the reaction of alcohol with phosphorus halides and thionyl chloride. In this reaction also alkyl chlorides are formed. Specific reactions you can what, that is the practice by taking the same, that is methanol, methyl chloride is formed, ethanol, ethyl chloride is formed, propanethiol, 2-chloropropane is formed, tertiary-butyl alcohol, tertiary-butyl chloride is formed. Now next one, reaction of alcohol, it is dehydration of alcohol. This reaction is called elimination reaction. It is called as dehydration of alcohol or elimination of reaction. You remember we have studied during the preparation of alcohol hydration of alkenes, and now this reaction is dehydration of alcohol. So what is the meaning of dehydration? Yes. Dehydration, आपल्याला डिहायड्रेशन होतं आणि आपण डॉक्टरकडे जातो, मग डॉक्टर सांगतात की डिहायड्रेशन झाले म्हणजे आपल्या शरीरातलं पाणी कमी झालंय. सो removal of water is called as dehydration. Removal of water is called as dehydration. So this water is removed from the alcohol. How it is removed? Reaction takes place by reacting or heating the alcohols with either concentrated sulfuric acid, phosphoric acid, phosphorus pentoxide or alumina, Al2O3. Strong heating, when we take the dehydrating agent, that is the alumina, then at that time it is strongly heated, and the dehydration of alcohol when takes place, then product obtained are what, that is the alkenes are formed. मी त्यावेळेस सांगितलं होतं की हायड्रेशन ऑफ alkene use alcohol, म्हणजे dehydration of alcohol gives the alkenes. Alkenes are formed or alkenes are obtained. Now see here, as we have studied, order of reactivity of alcohol is tertiary alcohol more reactive than secondary alcohols more reactive than primary. Means primary alcohols are least reactive and tertiary alcohols are most reactive. So here primary alcohol as least reactive, therefore they require higher concentration and higher temperature for the dehydration. Okay, we know the carbon atom which is attached to functional group in any organic compound is alpha carbon. Next to alpha, this is beta carbon. Next to alpha, this is beta carbon. So as the elimination of H plus ion takes place from beta carbon, this reaction is also called as beta elimination. This reaction is also called as beta elimination reaction. This is also known as beta elimination, as hydrogen removed from beta carbon. Okay, here I have shown that is OH is removed from alpha carbon, hydrogen removed from beta carbon, and from which two carbon there is removal of water. Between that two carbon, carbon-carbon double bond is formed and there is formation of corresponding alkenes. So ethanol, which is primary alcohol, when heated with 95% sulfuric acid at 443 Kelvin temperature, प्रायमरी अल्कोहोल आहे हा सगळ्यात जास्त कमी रिएक्टिव्ह म्हणून सगळ्यात जास्त कॉन्सन्ट्रेशन आणि जास्त टेम्परेचर प्रिफर केलं जातं त्याच्या डिहायड्रेशन साठी. सो इथेनॉल व्हेन हीटेड विथ 95% H2SO4 at 443 Kelvin temperature, ethylene is obtained or ethene is formed. That is nothing but the ethylene is obtained. Now second example, here we have taken secondary alcohol, more reactive than primary. So concentration of the acid and temperature required or favored is lower. It is less. Secondary alcohols undergoes dehydration with 60% sulfuric acid and low temperature, that is 373 Kelvin, as compared to primary alcohol. So isopropyl alcohol, secondary propyl alcohol, on heating with 60% H2SO4 at 373 Kelvin, propene is obtained. Propene is formed. OH removed from this carbon and hydrogen is removed from any one adjacent carbon because both adjacent carbon contains same number of hydrogen, equal number of hydrogen. म्हणजे इथे तुम्ही कुठल्याही एका adjacent कार्बन एटम वरून हायड्रोजन रिमूव्ह करू शकता and here propane is formed. Okay, so this is about the secondary alcohol. And see tertiary alcohol. Here example of tertiary alcohol, I have taken tertiary butyl alcohol or 2-methyl propane TOA. It is highly reactive. It readily undergoes elimination. So elimination of tertiary butyl alcohol takes place with 20% H2SO4. It is dilute or it is less concentrated and temperature also low because its reactivity is more. So when tertiary alcohols are treated with 20% H2SO4 at 363 Kelvin, then they produces the corresponding alkene. Example, tertiary butyl alcohol when treated with 20% H2SO4 at 363 Kelvin, it gives isobutylene or 2-methyl propene is obtained or 2-methyl propene is formed. This is nothing but the dehydration of alcohol. Here one more point I would like to tell you. This is the secondary butyl alcohol. Secondary butyl alcohol म्हणजे secondary alcohol ची आपल्याला कंडिशन यूज करायची 60% H2SO4, temperature 373 Kelvin. Okay, but here what happens? Ha alpha carbon atom and these are two beta carbon atom. Here two adjacent carbon attached to the carbon containing OH group does not contain same number of hydrogen. या दोन adjacent carbon atomवर हायड्रोजनची संख्या सारखी नाहीये. मग आपल्याला प्रश्न पडतो की कोणत्या कार्बन एटमवरून हायड्रोजन रिमूव्ह करायचा, या बीटा कार्बन एटम पासून का या बीटा कार्बन एटम पासून. तर आपण जर समजा दोन्हीवरून रिमूव्ह केला तर वेगवेगळे प्रॉडक्ट येतात आणि मग अशा वेळेस एक रूल यूज करायचा बा. अँड वी नो दिस रूल. द रूल इज सेट-सेप्स रूल. सेट-सेप्स रूल. यस. Okay, I am telling the statement of set-seps rule. When there are two or more choices to eliminate the hydrogen, then hydrogen is eliminated from that adjacent carbon which contains less number of hydrogen. इथून हायड्रोजन रिमूव्ह का करायचा. सेट-सेप रूल सांगतो की जर दोन किंवा दोन पेक्षा जास्त चॉईस असतील हायड्रोजन रिमूव्ह करण्यासाठी तर त्यावेळेस हायड्रोजन अशा ऍडजेसंट कार्बन एटमवरून रिमूव्ह करा की ज्या कार्बनवर हायड्रोजनची संख्या कमी आहे. कारण रूल असाही सांगतो की मोर सबस्टिट्यूटेड अल्किन्स आर फॉर्म्ड अँड देयरफॉर हियर देयर इज फॉर्मेशन ऑफ CH3, CH डबल बॉन्ड CH, CH3 plus here H2O. Name of the alkene is butene, that is 80%. म्हणजे major product obtained is what, that is the butene, and minor product 20% but1ene is also formed. In that case hydrogen is removed from this carbon atom and this is nothing but what, that is the dehydration of alcohol. And this one rule also here you have to remember, set-seps rule. Here one more point or one more reaction here you have to remember, that is nothing but the when the vapors of alcohol. Now here one more point here you have to remember, this is the liquid phase dehydration. It is the liquid phase dehydration. We can carry out the vapor phase dehydration. What is the vapor phase dehydration? That is alcohols, vapors of alcohol obviously are passed over heated alumina Al2O3 at higher temperature 623 Kelvin. Then they undergoes dehydration, product obtains same, only different dehydrating agent in that reaction we have to use, and that is called as vapor phase dehydration. Okay, see, we have studied just that is dehydration of alcohol, that was the liquid phase dehydration, and now vapor phase dehydration. So what is the vapor phase dehydration and how it is take place? Products are same. Vapors of alcohols when passed over heated alumina Al2O3 at 623 Kelvin, then similarly alcohol undergoes dehydration and they forms the corresponding alkenes. Corresponding alkenes are formed. इथे product तेच आहे, फक्त आपण जो dehydrating reagent आहे तो dehydrating agent चेंज केला, थोडीशी रिएक्शनची प्रोसेस बदललेली आहे. इथे अल्कोहोल वेपर फेज मध्ये घेतले and these vapors of alcohol are passed over heated alumina. These vapors of alcohol when passed over heated alumina, alumina removes the water from alcohol and it forms the alkene. So vapors of ethanol when passed over heated alumina at 623 Kelvin, it forms ethane. Product is same. With concentrated H2SO4 also it gives ethene. Then isopropyl alcohol when its vapors are passed over heated alumina at 623 Kelvin, it gives propene. Propylene is obtained. Or if you take tertiary alcohol, vapors of tertiary butyl alcohol when passed over heated alumina at 623 Kelvin, then it also gives the isobutylene or 2-methyl propene. So this is called as the vapor phase dehydration of alcohol.